In this video lesson, we are going to learn how to write chemical equations from word equations. So if you are only given the names of the substances of a chemical reaction in an equation format, you're going to need to translate those names into chemical formulas while maintaining the chemical equation format. So for example, this is what we call a word equation, where you have copper plus silver nitrate turns into copper 2 nitrate plus silver. So you need to translate copper into the symbol Cu, silver nitrate into the formula AgNO3, copper 2 nitrate into CuNO3 plus Ag for silver. Note, this equation is not balanced. We're not going to worry about coefficients in this lesson. We're just going to focus on correctly translating the words into chemical formulas. So what we need to do is we need to review how to write the formulas for the following compounds. So sodium oxide, remember what you need to do is you're going to need your periodic table. You're also going to need possibly polyatomic ion chart E. Sodium oxide. Sodium is the formula Na, and it has a charge of +1. Oxide is oxygen with a -2. So if we put those two together, Na +1 and O -2, if you recall the drop and swap, this becomes the formula Na2O. Potassium sulfate. Potassium is K+1. Sulfate is one of the polyatomic ions. We find it here. It is sulfate. It is SO4 -2. When we drop and swap, we're going to get K2SO4. Iron 2 chloride. Iron is Fe. It can be either a +2 or a +3. When you see the Roman numeral, it is telling you what the charge is. Roman numeral 2 is a +2. In the one down here, iron 3 is iron +3. Chloride, as you might recall, is a Cl with a -1 charge. So if we drop and swap, we are going to get FeCl2. And in this next one, we will get FeCl3. Lead 2 carbonate. Lead is Pb. Roman numeral 2, we don't even really need to go to the periodic table. We know that this is a +2. Carbonate. Carbonate is on reference table E. Carbonate is CO3 with a -2. If we drop and swap, what we might notice is +2 -2. The 2 to 2 ratio is going to simplify down to just 1 to 1. So this formula just becomes PbCO3. Lead 4 carbonate, Pb +4, carbonate, CO3 -2. When we drop and swap, right, we're going to get a 2 and a 4, but that 2 to 4 can reduce down. So this is going to become PbCO3 2. Zinc phosphate. Zinc is Zn. Zn on the periodic table is a Zn +2. Phosphate on the reference table E is PO4 -3. When we drop and swap, we're going to get Zn3, PO4 parentheses 2. Zinc phosphide. Zinc is a Zn +2. Phosphide, careful, phosphide is not on reference table E. Phosphide, when you see that IDE, it's just the monoatomic ion, so it's P with a -3. So this becomes Zn3P2. Okay, so that's going to be a helpful skill to use as we go about the business of writing chemical formulas from, or chemical equations from word equations. All right. So let's go through and just find element names, right? So here we have aluminum. That's just Al. Plus, we're going to bring down the plus sign. Okay, iron 3 oxide. I'm going to do my scratch work up above. Iron is iron plus 3. Oxide is O minus 2. When I drop and swap, I'm going to get the formula Fe2O3. Okay, so I've translated that. I'm going to bring down my arrow, and now I'm going to go to the product side. Iron, that's an element symbol. It's just Fe. I'm going to bring down my plus side, and now I have a formula that I have to figure out. Aluminum from the periodic table is a plus 3. Oxide from the periodic table is minus 2. When I drop and swap, I get Al2O3. There you have it. It's not a balanced equation, but that is a word equation translated. Let's try number 2. Sodium. Sodium is Na. Hydrochloric acid, I wouldn't expect you to know that one just yet, so I'll tell you that hydrochloric acid is the formula HCl. Don't forget to bring down all your plus signs. So Na plus HCl. Turning into sodium chloride. Now you might already know sodium chloride, but we know the formula is a plus 1 minus 1, so that's why sodium chloride is just NaCl. Plus hydrogen. Now hydrogen is one of those elements that is a diatomic. So whenever this element is written all by itself, it has to be diatomic. Again, this is not balanced, but that's not the point of this exercise. The point is to just translate the word equation into chemical symbols and a chemical equation format. Glucose. Glucose, C6H12O6, plus oxygen, it's a diatomic element. So that's O2. Bring down your arrow. Carbon dioxide, you probably recognize as CO2, plus water, you might know as H2O. Not balanced, but that is the translated word equation. Number 4, sulfur dioxide, right? So this is, we have a covalent compound. We don't need to do anything with the periodic table. When you see prefixes, it is telling you what the chemical formula is. 1 sulfur, 2 oxygens, so SO2. Oxygen, when it's an element all by itself, must be diatomic. Don't forget to bring down your plus signs and your arrows. Sulfur trioxide. So this has sulfur and it has oxygen. 1 sulfur, because there's no prefix at all, so that just means 1. And then tri means 3, so SO3. Again, this is not a balanced equation, but again, that's not the point of today's lesson. Number 5, lead 2 nitrate. Okay, so we're back to naming ionic compounds. Lead 2, that's Pb plus 2. Nitrate from reference table E is NO3 with a minus 1. Dropping and swapping, I'm going to have Pb, NO3, 2, plus sodium iodide. Sodium is a plus 1, iodide's a minus 1. So that's NaI, turning into lead 2, that's Pb plus 2, iodide is I minus 1, so this becomes PbI2, plus sodium nitrate. Na is sodium plus 1, nitrate NO3 minus 1, so that's just NaNO3. There you have it, not a balanced equation, but that was not the point. So in this lesson, you have learned how to translate chemical equations that are word equations into a chemical equation using the proper formula writing skills that you have learned about for both covalent and ionic compounds. That's it for this lesson. We'll see you back in the classroom.